Okay, in the previous video, we introduced stoichiometry using some of the most fundamental, simplest kind of stoichiometric conversions, going from moles of one substance to moles of another substance. But, as I mentioned, we are probably not going to have those type of simple problems on an exam, and you're not probably going to encounter those type of simple problems in a laboratory or an industrial situation. You're going to do something that's much more useful. For example, converting of grams or the mass of one substance to the grams of another substance. And so we need to be able to use our stoichiometry and expand it to being able to do a more complicated, more complex problem. So here I'm being given a certain number of grams, 5.4 grams of magnesium bromide. So we're given that substance right there, and we're given an amount of it and a unit of measurement of it, of grams of that. And we're being asked how many grams of silver nitrate would be needed to react completely with that amount. So I'm asked for grams of this substance. Now I want to point out I cannot use the molar ratios. I cannot use these coefficients to directly convert between grams of one substance and grams of another substance. The only way I can convert between two different substances mathematically is using the mole-to-mole ratios. So we're going to have to do that down here. So I'm going to set up my stoichiometry. How many grams of silver nitrate would be needed to react completely with 5.4 grams of magnesium bromide? So the grams of silver nitrate is what I'm looking for. Okay, and I'm given 5.4 grams of magnesium bromide, so that's where I'm going to start my calculation over here. Okay. Now, since I cannot convert directly in one step from grams of one substance to grams of another substance, and the only way that I can convert between two different substances is moles to moles, that means I'm going to have to convert these grams into moles of magnesium bromide, and then convert those moles of magnesium bromide into moles of the silver nitrate, and then convert the moles of silver nitrate into grams of silver nitrate. So it's going to be 3 steps here. So my first step, I'm going to use the molar mass of magnesium bromide to convert from grams to moles. Well, let's not worry about the numbers just yet. I'm going to just put in the units and the substance, grams of magnesium bromide. Has to be in the denominator so I can cancel that out, right? To moles of magnesium bromide. Okay, now that I've got moles of magnesium bromide, I can now use that to convert to moles of silver nitrate. And again, moles of magnesium bromide has to go in the denominator. And moles of silver nitrate in the numerator. So now I can see that the moles of magnesium bromide cancels. I'm going to move my equals sign a little bit further over because I need a little bit more space for my last conversion step. And moles of silver nitrate must be in the denominator here so I can cancel it out with it there. And I'm going to convert moles of silver nitrate to grams of silver nitrate. Grams of silver nitrate. Okay, so notice again what I've done. I've converted from grams of a substance to moles of that substance. Then moles of that substance to moles of a different substance. And then finally, moles of that final substance to grams of that final substance so that I'm done. I'd like to point out again that just as we did with above, we are going through a mole-to-mole conversion step. And that is very important to stoichiometry problems. And it is so important that I call it the heart of the stoichiometry. The mole-to-mole conversion step is the heart of a stoichiometry. You must go through a mole-to-mole conversion in order to do a stoichiometry problem. So now let's go back and fill in these numbers. Now something else I'd like to point out to you is that when we are using conversion factors, these conversion factors are molar mass conversion factors. This is converting from grams to moles, and this is converting from moles to grams, but they're both molar mass conversion factors. And molar mass conversion factors are always grams per 1 mole. And I see students making that mistake a lot. They will put in the number of moles from the coefficient in the equation, but no, we want the molar mass, which is the mass per 1 mole, and that's why it goes there. Another mistake the students make is that they'll put in this number of grams for that right there. But we know that this is the number of grams per mole. How do we calculate the number of grams per mole? Well, it's a molar mass calculation. How do we do that? We have to add up all of the masses from the periodic table. So I have a magnesium and 2 bromines, and if I do the math, I'm not going to show the work the math out, but if I do the math, I will get the number 184.113, 184.113. Didn't leave myself a lot of space there. And if I do the molar mass calculation for silver nitrate, there's 1 silver, 1 nitrogen, 3 oxygens. If I add all of those up, I get 169.87, 169.87 grams per 1 mole. And then for the heart of my stoichiometry, where do I get these mole-to-mole conversions? That comes from my balanced chemical equation here. That's why I had to have a balanced chemical equation before I could do my molar calculations. Okay? So, from my balanced chemical equation, the moles of silver nitrate, there are 2 moles of silver nitrate. And for magnesium bromide, it's 1 mole of magnesium bromide. And now I have all of the numbers that I need to do the calculation. If I plug everything in my calculator correctly, keep my parentheses where they need to be, make sure I don't multiply when I should have divided, then I will get an answer that gives me 9.9. Well, my calculator will tell me 9.9645 and several other digits. So remember what I have to do before I can move on. I have to check my significant figures. I only want 2 sig figs. That's 6 sig figs. These are exact numbers. 5 sig figs. The 1 mole is exact. So I'm limited here to 2 sig figs in my answer. Well, if I just try to round this to 2 sig figs, I get the number 10, right? When I try to round that, because that 9 makes that 9 round up to 10. But that's only 1 significant figure, isn't it? So there is no way to represent the number 10 in standard notation to 2 sig figs. So what do I have to do? Well, I have to represent that number in scientific notation. So it becomes 1.0 times 10 to the 1 grams of silver nitrate. And there's my answer with the correct sig figs, having to use scientific notation in this case because there's no way to represent the answer to 2 sig figs just in standard notation. Okay, so there's the calculation. I'd like to go over a couple of important things. Again, this is a stoichiometry problem, so we had to go through the heart of the stoichiometry, which is the mole to mole conversion step. This mole to mole conversion step is the only way that we can convert between two different substances. We cannot convert directly from grams of one substance to grams of the other. We have to go through this step. So you will always have a mole to mole ratio as a conversion step in your calculation for a stoichiometry problem. And we get those numbers from the balanced chemical equation, which is why it's so important to be able to complete and balance a chemical equation so that you can get this ratio, and therefore you'll be able to do these sorts of math problems.